All right, good afternoon once again. In this section, we have another question. Of course, it's still on mechanics, and in this question, the question read: in order to pull out the nail at B, at point B, there's a nail here. In order to pull the nail out B, the force F exerted on the handle of the hammer must produce a clockwise moment of 5 pound-inch. LB means pound, IN means inch, about point A. This point A. Determine the required magnitude of force F. So we're asked to find the magnitude of force F from this diagram. Remember when dealing with mechanics, the first thing we do is to draw a free body diagram, isn't it? So we draw a free body diagram of this hammer. This hammer is a little bit tilted, so it's inclined at an angle. And then this is just like the top of the hammer, that's here. So I'm from drawing from here, that represents here, and then I'd want to extend from the tip of the hammer, that's somewhere around here, to A. So I'll extend it from here to, let's say A is somewhere here. So this is point A, right? So if you have that to be point A, from the top of the hammer would have along the axis, perpendicular to the axis of the hammer, that's where this angle is being referenced to. This 30 degrees angle is being referenced, this line, that is this line. Then the force acts like this, right? So the force acts in that direction, and remember the force is pointing upward. Pardon my my heavy shading. So it's pointing upward, and then it's inclined at an angle 30 degrees to this line, right? So this is the top of the hammer where the force is acting. Then remember the distance from here to this point is 18 inches, right? So from here to here is 18 inches. So we have 18 inches here, 18 IN. Then the distance from here to here was 5 inches. That is the distance from this axis, this line. Remember, this line is just like the center line of this hammer. Is from here to point A is 5 inches. So this distance is going to give us 5 inches, right? So this is 5 inches. So with that covered, let's delve in. So the first thing we want to do is we want to resolve this force into two components. We want to resolve this 30 degree force because this is a force F. Let me denote it by F. So this is the force F at angle 30 degrees. So we'll resolve it into two components. We'll resolve it into one component along this axis or this line, then another component perpendicular to that line, that is along the axis of the hammer, right? So we'll call this, let's call this F sub X, then let's call this F sub Y. So we have those two components of force F. So we from our components on this thing. And by the way, in case you don't know, because most times students do complain, how do we know where these arrows of the components point to? You watch out for my other videos concerning that, because we'll be addressing that shortly. Remember, this is 5 inches, not sine, please. This is 5 inches. All right. So if you resolve this force F along F of X and F of Y, you would get, by using your trigonometry, your SOHCAHTOA, get F of X is equal to F times cos 30 degrees. That is this F. That's if you draw a triangle, you get that. So in that case, we'll end up with F of X is equal to 0.866 F, right? So that will be F of X. Then how about F of Y? F of Y is equal to F sine 60 degrees. From this diagram, if you resolve this force into two components, one is along the cosine, that one is along this axis, the other one perpendicular to it, you get these values. So from there you get this is sine 30 degrees, not sine 60, this sine 30. So F sine 30 is 0.5, so you get 0.5 times F, right? So that's our F sub Y. Once you've gotten F sub Y, the next thing to do is to find the moment of these various forces, F sub X and F sub Y. And remember, F sub X and F sub Y are now representative of the force F. So we are no longer going to consider F again. So taking moments of these forces, F of X and f sub y about point A, we end up with taking moment of these forces about point A, you end up with. Now, if you look very well, what type of moment does this force F exert on this hammer about point A? It tends to, like, because if the force acts like this, let's say this is your hammer, if the force acts like this, you tend to rotate the hammer in the clockwise direction, to tend to rotate it in this direction, that because the force F sub x is trying to pull the hammer or trying to push the hammer up, so it is going to be a clockwise moment. Similarly, the type of moment this force Fy exert on this side of the hammer is also clockwise, because if the force is acting in this direction, it's going to like turn the hammer in the clockwise direction. So both of them, they exert a clockwise moment. So in that case, they will both have the same sign or the same positive sign. So from here we'll have the moment due to force F of x is going to be, remember your moment is force times perpendicular distance, so that's going to be f of x times what's the perpendicular distance from f of x to, that's the line of action of the force f of x to A. That distance is equal to 18 inches, so that is going to be f of x times 18 plus the moment due to force f of y is going to be f of y times what's the perpendicular distance from this line to point A. This is the distance, that is 5, and you equate this to, remember he said the moment produce a clockwise moment, must produce a clockwise moment of 5,500 pounds in, so you equate this to 500, right? So from here we know that f of x, from my expression here, f of x is 0.866f multiplied by 18 plus f sub y is 0.5f multiplied by 5. Everything is equal to 500, right? So from here, if you multiply this by this, you should get 15.588. If you multiply 0.866 times 18, you get 15.588. Multiply by f plus 0.5 times 5, you get 2.5f, and you equate this to 500, right? So you add this together. If you add both of them together, you get 18.08, I believe 088 f should give you 500, right? So if you make f subject formula, you get f to be equal to 500 divided by 18.088, and this should give you f is equal to 27.64 pound, right? So 27.64 pound is the final answer to this question. Thanks for watching. I'll see you in the next video. And by the way, subscribe to my channel, subscribe to my page. I have a YouTube channel and I also have a Facebook page. And in case you want to see the second method for solving this without resolving these forces, I'll drop a link in the description or in the comment section for you to check out the solution on my YouTube channel. Thanks for watching once again, and have a nice day.